everyone, I am Andrea coming from BSIT 2E, and today we will learn about the rock forming minerals using their physical and chemical properties. So let's start! So our discussion will focus on learning competency, identify the common rock forming minerals using their physical and chemical properties. So do you consider water as a mineral? How about tube ice or snowflakes? Are these minerals? What are minerals? Minerals are the fundamental components of rocks. They are naturally occurring, inorganic, solid with an orderly crystalline structure and a definite chemical composition. Water is not a mineral because it is a solid and crystalline. Tube ice is not a mineral because it is a naturally occurring. But a snowflake possesses all the properties under the definition of a mineral. And now, we will discuss about the physical and chemical properties of rock-forming minerals. Let's start with luster. Refers to the way of light is reflected from the surface of a mineral. Types of luster, the metallic and non-metallic. Hardness. It is a measure of the resistance of a mineral to scratch. The Mohs scale of hardness measures the scratch resistance of various minerals from a scale of 1 to 10, designed by German geologist, mineralogist Friedrich Mohs in 1812. Color. Minerals display a variety of colors resulting from impurities and also from some geologic process like weathering. Example of coloring is azurite is purple, sulfur is yellow. Streak. Minerals color is in powdered form. Streak is a more reliable property than color because streak does not vary. Minerals that have some same color may have different colored streak. Crystal form or habit. It is the natural shape of the mineral before the development of any cleavage or fracture. And as we can see in the picture, there has a blocky cube, blooded habit, and needle-like habit. Cleavage. The property of some minerals to break along specific planes of weakness to form smooth, flat surfaces. Fracture. Minerals that do not exhibit cleavage are said to fracture when broken. Some break like glass, some into splinters of fibers. Last is the specific gravity, the ratio of density of the mineral and density of the water. This is the measure of water. Let's identify the chemical properties. Sample chemical test is done. For example, sulfur has distinctive smell. Halite is salty. Salsite fizzes with acid as with dolomite in powdered form. The most stable and less ambiguous basis for classification of minerals is based on their chemical composition. Silicates. Minerals containing the two most abundant elements in the Earth's crust, namely silicon and oxygen. Over 90% of rock-forming minerals belong to this group. We have also an oxides, sulfates, sulfides, carbonates, native elements, and halides. And these are the common rock-forming minerals. Quartz. Quartz is usually called silica, one of the most common minerals in the Earth's crust. It's made up of silicon dioxide, which is raw materials for making glasses. Plagioclase feldspar, which is an important industrial mineral used in ceramics. Alkali feldspar. It is commonly pink to white, used as raw material to make porcelain. We have also amicus, There are common minerals in intrusive igneous rocks and can also be found in sedimentary and metamorphic rock. We have also amphiboles. These are the family of silicate minerals. They are a component of many igneous and metamorphic rock. Pyroxene. This is the family of silicate minerals. Then these crystals are commonly faceted as gemstones. For instance, precious jade is a pyroxene. Next is olivine. It is a silicate mineral. Contains iron and magnesium. Calcite. It is a carbon mineral and it is made up of calcium carbonate. So now, we will learn about types of rocks and the rock cycle. Rocks coming from many different colors, sizes, and shapes. Geologists divide rocks into three basic rules. They are igneous, sedimentary, and metamorphic. Let's learn about each type one by one. Igneous rock. Inside the Earth's core, there are a lot of multi-materials and metals. They melt because of the temperature inside. The melt segment material put too much pressure on Earth's surface. Sometimes the surface breaks, and due to this, the magma comes out. When it comes out, it's called lava. It gets cooled gradually and changes into the basalt rock. The rest of the magma it doesn't see about stay inside the earth. The leftover magma inside it changes into granite. It's types of igneous rock. You may have seen structures made of granite because it's so strong. Another sedimentary rocks. They form when sediment compresses. Sediment is comprised of tiny rocks, plants, and dead animals. They reach the sea and they stay in the sea bed. Over millions of years, more and more sediment builds up and compacts, and it eventually becomes sedimentary rocks. Examples are sandstones and limestones. Metamorphic rock. These are the changed form of igneous and sedimentary rock. They form by great heat and pressure. They generally found inside the Earth's crust. Whether it's enough heat or pressure to form a rocks, for example, slate change from clay, and marble change from limestone. Now the rock cycle. It is the process by which rocks of one kind change into rocks of another kind. Magma is sent to be your surface. It cools and forms of igneous rocks. Next to these rocks, breaks into small pieces of sediment, and sediment builds up and hardens.